Math is great, math is okay. You will need in life every day. From pandas to functions, to fractions, to formulas.
You are given the following student work for question number 17. In number 17, I notice that they set the factor equal to 0, and then they have x equals -2. They have a odd shoot through based off its multiplicity, which is 3. That's correct. So if they go to -2, they have it there, but I think their graph kind of shows a bounce. I think it should actually go through it like that. Okay, let's take a look at their other one. X minus 3 is their factor. They set it equal to 0, and they have a 0, x equals 3. You look at their number here, that is a 2, and that's why they wrote even kiss, which is correct. So here, I also noticed they have x to the 5th power, which is their basic graph, which is like x to the 1st. So start down, end up. So the arrows are here. So as they're drawing their sketch, I think their graph should be a little bit higher. So on their original graph, it doesn't really, it doesn't have clear, let's write that down. Number 17, I think was more, wasn't completely correct, so I'm gonna write incorrect. Why? When graphing, their multiplicities, they can show a more clear bounces or kisses and shoot throughs. Okay, in question number 18, I noticed that the student did this, and I wonder if they were trying to get the GCF, right? You could have broke it up, x minus x minus 6xx. Class, what do they have in common?
X squared.
Yeah, x squared. So that student has the x squared here, and then I have x squared. They didn't really write it, so let's just write it. -x minus 6. Okay, a couple of students missed this on the quiz, your last quiz I just passed back. What's in front of the x, or the -x? What number? -1. And you can kind of see that over here, a times c. That's your b value. Those are the two numbers. Okay, so the student went from, let's do purple. They went from the factors, and I want to write x squared as something that might help some of you. Right? You always want to see those factors. And the 0 for that is just x equals 0. Class, the multiplicity is what number? 2. So that's a kiss. Okay? So I noticed that the student doesn't have that. Do you guys see that? Raise your hand if you saw that. Okay? And the other ones would look fine. So let's just redraw ours. Blue, x equals 3. Let's do green, -2. And purple is where? 0. Class, where are my arrows? Are their arrows correct? Yeah, they realize as to the 4th power, And the number of 4 works, right? 1, 2, 3, 4. So that gives you to the 4th, and it gives you right here.
She asked if you're going to reimburse her.
Yeah. Okay, so let's sketch left to right. At a negative 2, we have a multiplicity of 1, so I'm going to shoot through. At 0, we should... Sorry, I can't zoom in anymore. Try this. We're going to bounce off the... Why did I choose the same color? Let's try blue. So we're going to bounce off. And then I have to shoot through 3 and go towards the exit. Okay? So if I had to explain what the student did incorrectly, I would write something like this. The student's work, can you see that?
Yeah.
Does not clearly show x equals 0 as a 0. Class, what's another word for 0? Solutions, what else? Root, what else? Yeah. That's what I think they were missing. All right, in question number 19, let's see what we have here. The student was supposed to graph x minus 3, x plus 2 squared. Now this function is called g of x. Now the student knew that it was factored because they have parentheses. Okay, then they were asked to do the basic graph. But the student thinks that it's quadratic because it's the power of 2. Maybe because they only see one number. The class, they are missing what number?
1.
They're missing a 1. The basic graph should be 1 plus 2, which is what? 3. That changes where the arrows are. Remember, the easiest odd is what? X to the first power. Okay? So that is down, then up. So their arrows should not be there. Let's do it correctly. They should have their arrows down and then up. Okay? Every odd degree is like that. Let's check their multiplicity. So over here on the far right, they got a factor in purple there to a 0. Okay? Now they know that at x equals 3, the multiplicity is 1. I'm going to write m equals 1, and 1 is odd, so it's a shoot through. Okay, so at 1, they're going to shoot through there. Then x equals, they're going from a factor of x plus 2, subtract 2 to both sides, they get x equals negative 2. That one has a multiplicity of 2. That one didn't show up. Let's try that again. Multiplicity of 2. So that's going to be a shoot through or kiss? Kiss. Okay. Let's do one more. Let's do the y-intercept. We're going to make every x value equal to what? 0. So if I put in 0 here, 0 minus 3 is negative 3. 0 plus 2 is 2. 2 to the second power is 4. 4 times negative 3 is negative 12. So let's just put that down here. Okay, so let's go ahead and sketch. Start on the left. At negative 2, it's a kiss. Kiss and run away. We're going to go through negative 12. I'm going from left to right. Then at 1, it's a shoot through. So my graph should look something like that. Okay, so let's write the mistake the student made. The student forgot the degree to the factor. I don't know if I can change colors. Let's see if I can do that. Tink. The student forgot the degree to the factor of x minus 3 is 1. Right? 1 is right up here. Okay?
Class, what's the first thing I need to do?
Find the degrees.
Okay. So we're going to make sure it's in factored form. They're factored. And now I'm going to find a basic graph. Class, what's the highest degree for this one?
2.
X squared. And this one will just be what?
1.
X or x to the first. And if you multiply, what do you get?
3.
X to the third power. Class, is that odd or even?
Odd.
And what's the easiest odd that we know? X to the first. What does that look like? It's a line. Starts down, ends up. So our graph's going to do the same. It's in factored form. I found the basic graph. What's next?
Multiplicity.
Let's do the multiplicity. To do the multiplicity, I'm going to have to do what?
Make it equal 0.
So we're going to have to do the zero product rule. If this says x minus 4, then x is equal to
Plus 4.
positive 4. Class, what's the degree here? So I'm looking at the outside there, degree of 2. And then is 2 an odd or an even? And you're going to
Good.
kiss. Class, the other x value is? So again, you're just kind of setting those. Zero product rule basically means you set it equal to 0, each one of those, right? And you just solve for x, so x equals negative 1. What's our degree there?
1.
So there's nothing there, so it is a 1. Odd or even? Kiss or shoot through? Straw graph. I want to model something as I do this. Let's just say you have your x values. If they are crunched up, you can always count by 2's, right? Half, then 1, 1 and a half, 2. Does that make sense? Give yourself plenty of space. You don't want it smushed. So I have x equals 4. Write the number 4. And x equals negative 1. And then I'm going to have an arrow to the left of your furthest left one, so that would be negative 1. And then I'm going to end up, so remember going from left to right, so I have one up here. Class, what happens at negative 1?
Shoot through.
So we're going to go through it. And you can also find your y-intercept if you wanted another point. So 0. 0 minus 4 is?
Negative 4.
Negative 4 squared.
16.
And then 0 plus 1 is 1. 1 to the first power, and 1 times, what did you guys say? So this graph actually goes way up there. So, I don't know, put something way up there. That's what's happening. Something way up there, right? And then, as I approach 4, what's going to happen?
You gotta kiss it so you can like very quick.
it's going to bounce off. It's going to bounce off the x-axis. So my graph's going to look something like that. Take out your calculators. Let's go ahead and look at our calculator and see what this looks like. So make sure to use your parentheses. X minus 4 squared. Times quantity x plus 1. Then I'm going to press zoom 6. And I have all this space on the left side, so I'm going to go ahead and change my x values here on the window. I'm going to change it to like something like -3, maybe like x equals 6. I also notice up here that it's getting, my graph's getting cut off, so I can change a higher y value, but I also can shorten up the y values on the minimum. So x value maybe like -2. Notice how I'm just going to the left of my graph. Over here, maybe 5 or 6. The y values we didn't need too much, so -5. Y max we already calculated it to be 16. So you can go a little bit higher than 16, maybe 20. And I'll count by 5s. And if you press graph, we've actually changed the window of our graph. And there you can see the shoot through goes through 16 and then comes down, kisses off of 4, and then continues on towards positive infinity. Okay, so the goal of us doing multiplicity here is actually to graph this without the calculator. So that is our goal by Friday, so that you're confidently graphing a polynomial without a calculator. Alright, to do this problem, the first thing I'm going to do is I'm going to see if it's factored. It's factored. The reason why I know it's factored because you have the parentheses there, and there's a GCF. You'll know that it's not factored if it's kind of like in a descending order, which we'll do tomorrow, which you'll have to factor it before you do the problem. So this is already in factored form. The second thing is I need a basic graph. To get a basic graph, I'm going to take just the highest degree of the exponent. So here's x. This one, you could expand it as x minus 3 times x minus 3, x squared minus 6x plus 9, right? But just to a shortcut, the highest degree is going to be x squared. And this one will be x. So to find my basic graph, if I have all of the same base, you just need to add the exponents. And that'll give us what class? X to the 4th. Now, is 4 even or odd? Even. I have to think back to what is the easiest even one we know.
Quadratic.
It's a quadratic one. And in a quadratic one, I have x squared. So think back to the easiest one you have, and notice if you draw yourself a quick graph, the basic graph says this. Opens up, starts up, ends up. Okay, so this is my basic graph. It's going to mirror an x squared. The next thing I'm going to do is multiplicity. To do multiplicity here, I'm going to use the zero product rule. The zero product rule essentially says that each of these equal to 0. X minus 3 equals 0, x minus 3 equals 0. Notice I wrote this twice, didn't I?
Yeah.
But when I solve it, I already have one here. So the first one says x equals 0. The next one here, if I solve this, this says x equals 3. Now, pay attention. I don't want to write the x equals 3 twice. So that's why they call it a double root. And then this one class will be x what? X equals negative 5. The next thing I'm going to do is look at the degree that it has. So this one right here has a degree of 1. The degree of 1, is this odd or even?
Odd.
And odds, do we do kiss or shoot through?
Shoot through.
X equals 3. Its degree is 2. This 2 is an even number. And you will kiss. And the last one, its highest degree is what?
1.
1. Odd or even?
Odd.
Shoot through or kiss?
Shoot through.
Let's go ahead and give yourself a graph now. The first thing I'm going to notice is, just to give myself a hint, I like to use a pencil, is the graph is going to end up, or start up, sorry, we're going left to right, and then it's eventually going to end up. Okay, and now I'm going to go ahead and draw my x-intercepts. Let's write the numbers there, 0, 3, and negative 5. So when I approach negative 5, I'm going to shoot through the x-axis. So here's my starting point. I need to get to the other arrow. I'm going from left to right. So you can notice I'm kind of going through. Put a check mark. And I'm approaching 0. So at 0, I'm going to have to shoot through it. And then when I approach 3, though, I need to do a kiss. So I go towards 3, kiss, and then run away. Notice how it's not going through the x-axis. And I need to end up here. And this is my graph in factored form of graphing this polynomial. Alright, let's go ahead and do this one. So I have c of x equals negative 1/2 times x plus 1, x minus 2, x minus 3. Class, is this factored? Yes. Let's get a basic graph. All of this will give me what? X times, which will give us x to the third. Class, is that odd or even? This is an odd number. Class, what's the easiest odd number you know? X to the first. Draw yourself a quick graph. And you'll start down and up. But this problem says the negative. Are you following me? I don't care what fraction is, just it's a negative. So this will become negative x to the third. Negative. Easiest one is negative x to the first. That means it's going to start up and down. Okay, there's your clue. Let's go ahead and do the multiplicity. Girls, x is equal to?
-1.
Girls, what's your degree there?
1.
And your odd or even? And you said shoot through. Boys, your next one? Right, you're setting that zero product rule, x minus 2 equals 0, so x is equal to 2. Boys, degree? Odd or even? Strike or shoot through. And then the last one, boys. Degree? Odd or even? Shoot through. Let's draw a graph. So I have x equals -1. I have x equals 2. And I have x equals 3. I'm using a pencil so I can erase. Remember, our blue here is a negative leading coefficient. So this leading term, everyone say leading term, tells me now it's going to flip the parent graph, right? So start up, so I look at the furthest left of my values, and I'm also going to end down. So this is going to be my starting point, and eventually I have to get there. So let's go through -1. What happens at -1, class? So I got to go through there, right? You could determine the y-intercept by making x equal to 0. Not important to me right now. And at x equals 2, what do I do? Tight, 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 and then what?
Shoot through.
Shoot back through, and I got to go back to the end point. Does that make sense? And there's our graph. So let's get an example here. I just wrote down the steps. Here's our example. F of x equals x minus 1 squared, x plus 4 to the third power. So let's just go through those steps. Question: is it factored? Yes, it is factored. I know it's factored because it has parentheses. Okay, next thing, basic graph. Well, a basic graph is looking at the exponents. Now, you could expand this, right? X times x minus 1 times x minus 1, and then you would do 4 on the box, and then you would multiply by x plus 4, and then x plus 4, and then x plus 4. That'd be pretty crazy, right? So, just generally, this is not algebraically accurate, but essentially what we're doing here is we're just going to get an x squared. And here, this is going to be, again, this is not a property of exponents, but what we're doing is we're just kind of getting a basic graph. X squared times x to the third is x to the fifth. And what does that basic graph look like? Class, is this odd or even? This is an odd. What's the easiest odd degree function we know? X to the first. So that's going to start down and up. Okay? So I know my graph's probably going to look something like craziness like that. Okay? It's going to start down and then end up. So that's just basically what a basic graph looks like. Okay? And we're going to sketch it more with more details. Let's go through the multiplicity now. With the multiplicity, we're going to do the zero product rule. So I'm just going to set one of the parentheses equal to 0. And the reason why I'm not going to write out every single one, x minus 1, and then x minus 1 equals 0, I don't want to do the same problem twice. Does that make sense? And then I have x plus 4 here equals 0.
And then to solve here, you just add 1 to both sides. Therefore, x is equal to 1. So let's write that. One of my zeros is x equals 1. Let's make a chart. Let's write the degree. And then we'll write if it kisses or shoots through. Okay? Over here, I'm just going to subtract 4. So I have x equals negative 4. Okay, so we've basically done the zero product rule. Okay, let's look at x equals 1. So this is a big idea here, okay? X equals 1 is the same thing as the binomial x minus 1. X equals 1 is the same thing as the parentheses x minus 1. I just showed that to you, right? So we look at its multiplicity here. Multiplicity. Let's write that. Another word for its degree is its multiplicity. Put a 2 here. Class is 2, even or a odd number. And what do you do at evens? You kiss. X equals negative 4. What's its multiplicity? It's a 3. 3, is that an even or odd? You're going to shoot through. In this problem, there are no transformations or shifts. What that would basically look like if there were some a values in the front, like a constant, or another constant back here, like a minus 8. So we don't have any of those. Let's go ahead and graph this now. I know on my x-axis I'm going to have a 1 and a negative 4. So let's kind of plan for that. And kind of more on my left side. Alright, let's graph x equals 1. This was here. X equals negative 4. So x is equal to negative 4 here. And the basic graph here, basically, it's really talking about its end behavior. So we talked about how it kind of starts down and ends up. So in our problem, it's going to start down and end up. And then you're going to take a pencil. Everyone say pencil? It's just easier if you do pencils. Okay? So, here's my arrow, my end behavior starting there. And it tells me to shoot through. So I got to go through the yellow point. And then as I approach the pink, it says to kiss or bounce off. And then I'm going to finish by going up. Okay? And basically what we did here is we just basically sketched a polynomial without using our graphing calculators. That's the goal. So we can actually verify it on our calculators. I think on this next quiz, I'm going to say no graphing calculators. So if you've been kind of just like having the calculator pass the class, that's a bad thing. X plus 4 to the power of 3. Reflections. Assume 6. And at least we have a basic idea, right? It shot through. It went up super high, comes back down, bounces. And I can kind of tell my graph up here is not as accurate because there should have been more turning points. Okay? But the big idea is that we're just looking at what's happening here.
kind of give you an idea. Let's change the window. Ymax 100, 10 graph. Okay. So that's how you graph a polynomial by its x-intercepts. Giselle, which way did you want to do number 15? Did you want to do that as a x box or quadratic like? Okay, this problem you get to choose because it's what? Is it Michael Jackson? No, it's quadratic like. Does that make sense? Alright, let's do it. Giselle, what's my A times C? 12, and my B value is? 7. So that becomes from A, B, and C. Giselle, two numbers that multiply to be 12 but add to be 7. 4 and 3. Class, do you have to use the box for this problem? No. Now, if you don't understand that, okay, just do the box. Let me show you why this is not wrong. Partner A, tell partner B what goes inside the box. 30 seconds. Fabio, fill out the box. Correct.
Top right is 3x squared.
Correct.
Bottom left is 4x squared.
Correct.
And the bottom right is 12.
Here's your yellow. These are your greens. And this is your pink. Remember, in the green you have to add x squared based on that problem. Help us get what's on outside of the box, Christian. Here? Okay, x squared times x squared is x to the fourth. What are you going to put here? Right, x squared times 3 is 3x squared. What goes over here? X squared times 4 is 4x, and Christian, 4 times 3 is 12. Christian, what do I write in my binomials? Okay, because I checked two papers, I want to prove to you why you cannot simplify x squared plus 4. Okay? I went around and saw this, x plus 2 squared, and I also saw x minus 2x plus 2. That tells me you don't know when to factor. You're kind of just like guessing. Let's just say you did the x box method, x squared plus 0x plus 4. A times C is 4, B value is 0. Class, are there any two numbers in the world that multiply to be 4 but add to be 0? There are no two numbers, because in order to add to be 0, this number and this number have to be opposites. Positive 2 and negative 2. But if this is positive 2 and negative 2, this would have to be a what? Negative 4. That's why they call it a difference. Subtraction of squares. So it's not this one. Let's just say you thought this was the answer, which I saw on a student's paper. It's x plus 2, x plus 2. And then if you multiply it out, you'll get x squared plus 4x plus 4. Is that what it says, class? No, the b term is 0x, and I can check that by multiplying it out. Okay, so be careful. Be careful.
Alright, let's go ahead and find the zeros. To do that, I'm just going to, let's see if we can factor. We have 3 terms. Half of 4 is 2, so that means I can use my X box method of factoring. my A here is 1, B is -9, and C is 14. A times C is 14, my B value is -9. My two numbers are going to be 7 and 2. I want these numbers to multiply, but the same two numbers add, so I'm just going to make both those negative. Okay, these two are splitting this term, so that'll be a negative 7x squared and a negative 2x squared. A value goes on top, C value goes in the bottom right. We're going to think of things that multiply to be x to the 4th. So that'll be x squared, this will be -7, and this one will be a -2. Okay, so that's the answer for factor there in purple. Now let's just test if they can factor anymore. Remember, you can do a 0x. So I get a trinomial, and then we can factor here. -2, 0. And there's no number, so that just basically means that's the best thing we can do. And then green here, same thing. So now that we factor, let's go ahead and set these equal to 0 and solve. Let's do this one on the right. Okay, so to get rid of the power of 2, you take the square root, and you're going to have two solutions. It's going to be a plus or minus radical 7. Now when we graph that, just to give you an idea, it's pretty close to the square root of 9 is 3, and the square root of 4 is 2. So it's closer to 9 than it is closer to the square root of 4. So I'm going to guess it's around plus or minus 3, okay? Let's do the same thing over here, solve it. Square root plus or minus square root of 2. And your choices here are square root of 1 and the square root of 4. So it's closer to 1. So I'm going to say that one's probably going to be close to x equals approximately plus or minus 1. Okay, so I have this here in yellow. Let's go to purple. Let's go ahead and graph these. Okay, so I know that the C value is the y-intercept. And I know it's a quartic to the 4th power. So I know that the easiest one is x to the 2nd, so my arrows are going to be up. And then we set in purple that's near plus or minus 3. So if I said this was 3 and this was -3, we're saying it gets close. Probably a little bit less than that. Same thing with the yellow. If this was -1 and +1, it's probably going to shoot through pretty close. Okay, let's go ahead and sketch our graph here. We'll start with the left. We're going to shoot through. So near -3, probably a little bit less than that. A little bit more than 1. Okay, so here's my graph. And Pretty close, right?
Beta, what do you want to do first? Trying to factor this completely.
So I took out the greatest common factor.
Ooh, who saw the greatest common factor? Here's the trick. Beta, what's half of 3? See? It's not 1.5. So although it's a trinomial, you shouldn't be using the Xbox method yet. Does that make sense? Do GCF. Okay, what's left?
3x squared plus 2x minus 7.
Vita, what's half of 2?
1.
There you go. Good job, Vita. Alright, Charlotte, what do we do? What's A times C, Charlotte? Positive or negative? Charlotte, positive or negative? Your B value? Remember, it's ax squared plus bx plus c. That's where we're getting their a, b's, and c's from. They're the coefficients. Charlotte, two numbers that multiply to be negative 21 and add to be 2. None. Raise your hand if you got none. It just means that the yellow part is prime. What does that mean? It just means the only thing you can factor out is just 2x. And that's your answer. Okay, now let's just say I wanted you to graph this problem by multiplicity. This would be very painful. You would set that equal to 0, set this one equal to 0. You can't solve by factoring, you can use the quadratic formula to find those other two values. But for now, I just want you guys to practice your factoring.
How do I know if it is a prime or not?
Okay, so how do you graph this one? You would just set them equal 0. This one, we just saw that it was not factorable, so you could just use your quadratic formula. I'm gonna guess that's somewhere close to the square root of 81, which is 9. Just for all purposes, I just estimating here. Negative 9 plus 9 is 7 over 6. And then negative 11 over 6. Approximately. I mean, those are close. Let's just get the square root of 85. Yeah, it was 9.29. So not too far off. So then if you make your quick sketch, x equals 0, something around here, one's a negative. So positive, negative. This is cubic, positively in coefficient. They're all shoot-throughs. Now, if you don't know how to get a shoot through on these, you know, essentially the factor is this. These are again estimates. So that would be x plus 1.83, because then you would set it equal to 0 and be negative. Okay? Okay, so if you simplify negative 2 plus or minus square root of 85 divided by 6, you'll get these values. You could just punch in your calculator, but that's what you would get.
Factor each polynomial over the set of complex numbers. Use the factors to identify the zeros and then sketch the polynomial. So they just want you to factor. Raise your hand if you used, what do we call it? Chunking. Raise your hand if you did chunking. Okay, if you did chunking, this is my quick work to this. My same number there is x squared. And essentially what happens is that x squared becomes whatever I chose, and that was in this case u. So I have u squared minus 10u plus 9, so instead of writing x squared, I'm writing u. And then I just factored that. Okay? But for those who are doing Xbox method, let's do that together. Remember, we've been learning that if you have a trinomial, 1, 2, 3 terms, class, what is half of 4? 2, you have a, b, and your c value. Okay, so let's go ahead and use that to factor. Class, a times c. B value. Two numbers that multiply to be 9 and add to be negative 10. Negative what? Negative 9 and negative 1. Now, because your a value is equal to 1, you don't need this next step. I want you to hopefully clearly see why it comes out to be the answer that we're going to show you in a second. And this will actually help with today's lesson. So we're always going to put the first term in the top left. So that becomes x to the 4th. I'm always going to take the middle term, which we just split, and pay attention, remember that is x squared. So negative 9x squared and negative 1x squared. And then I have positive 9. Let's focus on the x, or the box now. Class, what's your greatest common factor? X squared. How about this direction? Negative 9. How about up here? X squared. And over here? Negative 1. Remember, you have to multiply to check your answer. X squared times x squared is x to the 4th. Negative x squared, negative 9x squared, and then positive 9. So my answer to factor this is x squared plus 9, x squared minus 1. It is a minus 9 because I made a mistake. Thank you. Tell your partner why I left a big space in the middle. Class, is this A, B, or C? A, B, or C? What's my B value? 0x. And the reason why I did that is because you have to factor again. So let's get an answer from my blue here. A times C is negative 9. My B value is 0. Partner A whisper to partner B, what are the two numbers?
32.
Leslie P, what are my two numbers? Sade, what are my two numbers? Will -9 and 0 add to be 0? So let's write that over here. So I have x minus a -3 and x plus 3. Let me do the same thing for the orange. A times C is -1. B value is 0. Partner B whisper to partner A, what are your two numbers? Annalyn, what are our two numbers? Two numbers that multiply by -1 but add to be 0. -1 and +1. Alright, let's review what we've done so far. It tells us to factor each polynomial. So I have a higher degree polynomial, and I use my Xbox method of factoring. And I get these. I factored it again, because I can keep going, and now I have something called these linear factors. Why are they called linear factors? Because x is to the power of what? 1. Now, we're going to do the second part where it says identify the zeros. So all that means is set it equal to 0 and solve. Let's do that. So I set each of those binomials, or the parentheses, or the factors equal to 0. Nathan, here, x equals negative or positive? How about right here? Here? And here? -1. So we've factored, we've solved or identified these zeros, and now we're going to make a sketch. So I'm going to put those onto my graph. -3, -1, +1, and +3. Class, do you have a even or odd degree polynomial? It is a even degree polynomial because of this 4 right here. So what I'm going to do is the arrows start where? Up. And end where? Up. Don't forget you have a +9 as your y-intercept. And if you remember from last semester, these are all to the power of 1, so your multiplicity is 1. Those are odds, that means they're going to shoot throughout each of those values. Let's draw a sketch. So I'm going to go from left to right, so shoot through it. And a lot of quartic polynomials look like W's. So in this problem, you had to factor it, solve it, and then sketch it.
Missing formulas in life, problems becoming too difficult to clear. Well then, you need Mr. Math Cleaning Solution. Just spray the liquid formula onto the mess, then wipe it clear, and enjoy the result. Mr. Math. stay clean and calculated. Order now at www.gpproductions.com and get an additional